Are we recording? Are we live? Yes, we are. Welcome back to geometry. And I don't see the mic moving. Alright, here we go. Let's try that again. Chapter 7.4, Parallel Lines and Proportional Parts. Okay. And there we go. The triangle proportionality theorem. Alright. Here, if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. Alright, so that means AB to BC is proportional to AE to ED. Alright, so let's look at this one. We know that these two sides are parallel and we have measures for these, so I'll label that and then we can set up a proportion. So for example, x to 2.5 is proportional to 7.5 to 3 because these two sides are parallel. Cross multiply to solve, boom, x is 6.25. On the other hand, going backwards the other way around, if these two lines intersected and making these proportional segments, then they are parallel, then this line is parallel. Alright, so for example, we could check to see, are these two lines parallel? Well, we've been given these measures. Okay, we know that DG is 1/3 the length of GF, so 1/3 x there. And we can again set up our proportion. So we'll do x to 1/3 x is equal to 9 to 3. Cross multiply, and we get 3x is equal to 3x. And the ratios are equal, so the sides are proportional. Okay, the midsegment of a triangle. Midsegment, a segment with endpoints that are midpoints of two sides. So this line right here hits the middle of this line, okay? And it hits the middle of AB. So every triangle has 3 of these mid-segments, and there are some special things about those mid-segments. A mid-segment of a triangle is parallel to one side of the triangle, so this mid-segment is parallel to FG. So JK is parallel to FG, and the length of JK is half the length of FG. So the mid-segment is half the length of the side it's parallel to. Alright, so here we go. We know that x and y and x and z are mid-segments of this triangle. We want to find the measure xz. Okay, well, we know that xz is half of RT. So half of 13, so xz is 6.5. Pretty easy. Alright, then we want to find st. Well, we know that xy is half of st, and we know that xy is 7, and so half of st, or st over 2, multiply each side by 2, and we get st is 14. If we want to find this angle right here, ryx, okay, we know that this measure here is 124, and we know that ryx is congruent to rts, because these mid-segments, these are parallel, so we know that those are congruent. And there we go, so we know that that measure is also 124. Alright, proportional parts of parallel lines. If 3 or more parallel lines intersect 2 transversals, okay, so there are 3 parallel lines and then 2 transversals, they cut off the transversals proportionally. Okay, so AB to BC is the same proportion as EF to FG. If 3 or more lines cut off congruent segments of one transversal, then they cut off congruent segments on every transversal. So if these two segments here are congruent, that means that these two segments are also congruent. Alright, so we want to find x and y. Well, here we have indicated that these two segments are congruent. That means these 3 transversals are cutting off the 3 parallel lines are cutting off the transversals into congruent segments, so these are also congruent. So we know 6x minus 5 is equal to 4x plus 3, and then I'll solve that, subtract 4x from both sides, add 5 to each side, divide by 2, and we get x is equal to 4. We also know that the other two sides are equal if they're congruent, so we solve that, subtract 3 from each side, add 7, divide by 2, and y is 7.5. And that is all that we have for today. I will talk to you another day.